Hi folks, this is question 9. So the first bit is quite easy really. We're just going to put a 13 in instead of R, and we're going to put a 4 in instead of K. So we're going to get pi times 4 squared over 3, and then multiply that by 3 times 13 minus 4. And then you put all that in the calculator, you get 560 over 3 pi. And they want you to give your answer in terms of pi. Right, so for this then, I'm just going to let 36 pi y, I'm going to let that be equal to what we had up here. So I'm going to let it be equal to this, but this time the radius is y and not k. So it's going to be pi y squared over 3. And 3r minus y. And hopefully we'll come up with this then. So, well, I cancel out things on both sides. So if I cancel out the pi's on both sides, I can cancel out one of the y's. So just that y. And then, yeah, it works out then quite simply, doesn't it? Sorry, radius is actually, it says in the question, is 8, so I can put in what the radius is here as well. So, right, so I'm just left with y over 3 times 8 minus y is equal to 36. So I could have put the 8 in initially. So y over 3 times 24 minus y is equal to 36. So I've shown that then. That's all we need to do for B part 1. Now, we're just going to multiply out then, we're just solving for y here. So if I multiply by 3 on both sides, I get y times 24 minus y is equal to 108. Then 24y minus y squared is equal to 108. Then y squared minus 24y, bring over, so plus 108 when we change the signs is equal to 0. So just bringing everything to one side there. Now, easiest thing is probably put it into the minus b formula there. So a is 1, b is minus 24, and c is 108. That's the easiest way. I probably just put it in there, or you could try and factorize it. It does factorize nicely, but it has to be minus, so it's going to be y minus 18 and 8 as well. So y minus 18 is equal to 0, or y minus 8 is equal to 0, so y is equal to 8, or y is equal to 18. So yeah, it says back up here though in the first part that y has to be between 0 and 8, so 18 does seem too big for it there as well, so we can get rid of that one, so y is equal to 8. Right, so part C, so 3 litres is given to us. It's straightforward enough, but the 3 litres, we have to know what that is in centimetre cubed, because this function tells us in centimetre cubed. So the conversion is that 1 litre is equal to 1,000 centimetre cubes basically. So we just have to convert 3 into 3,000. So it's just going to be pi over 12 x cubed is equal to 3000. And then we solve for x. X cubed is equal to 3000 over pi multiplied by 12. And then we're going to do the cube root of that, because obviously we need to get what x is. Then they wanted the nearest decimal point as well, so it's 22.5. It's going to be in centimeters. Right, so part D then is harder again. Right, so the volume of the hemisphere is increasing at a constant rate. So if it's increasing at a constant rate, that's with respect to time. So the volume, so dV dt with respect to time, the volume with respect to time has to be equal to 450 here. So these questions are all about writing down what you have. Now we also have that V is pi over 12 x cubed. So if I differentiate that will give me dV in terms of x. So dV dx. So that would be do 3 multiplied by the pi over 12. That gives me 3 pi over 12. And then it's just x squared. So now I have dV dx and I have dV dt. What I'm trying to find here is I'm trying to find the rate at which the diameter, which is x, so I'm trying to find dx with respect to time. So it's with respect to time, so it's dx dt. That's what I'm looking for here. So that chain rule, that would be dx, and the other thing I have in here is a v, so dv multiplied by dv dt. So I know what dV dt is, it's the 450, so 450 would be there. Now dx dv, I don't have that yet, but I have dV dx, so you're allowed to just flip it over then. So dx dv, if dV dx is 3 pi over 12 x squared, well then dx dv would be 12 over 3 pi x squared. Now it's when x is 20 as well, so we can put a 20 in instead of x. So when I'm putting it in here, then I'll just do that. So 12 over 3 pi times 20 squared, and we just multiply all of that together then. So if you go ahead and put all that in, you should get 1.4. So that's it. And that's the rate at which the diameter is increasing. So it'll be in centimeters. Right, here then we just have to rearrange around. So first thing I'm going to do is I'm going to square both sides. So we get s squared is equal to, we have to square everything then, so pi squared r squared, and then r squared plus h squared. That just removes the square root there. Then let's bring across the pi squared and the r squared then and divide them. We're trying to get isolate so pi squared r squared like that is equal to r squared plus h squared. Now we need to fit it in then into the way they want it over there. So let's bring over the r squared first of all. Now we get s squared over pi squared r squared minus r squared. is equal to h squared. So let's put all that to the one fraction then. So the common denominator then would be pi squared r squared. And on top we're going to get s squared minus, and then I have to multiply r squared by pi squared r squared. So that would be pi squared r4 is equal to h squared. And now all we need to do then is just square root both sides. So h is equal to the square root of the bottom would just be pi r. The square root of the top would be it's just s squared root of s squared minus pi squared r squared. And that should, I think, look like that then. Sorry, it's r4, isn't it? I should write down squared by mistake. So r s, so a, b, and n. So a then is the thing in front of the r, so a is pi squared. N is the power, so n is 4. And pi r, so yeah, b is just going to be pi. And then that's all then for that question, I think.